right now we have to start from the battery, so we can change the direction of the battery like this but I just put the space here, see, so it can change the direction of it. And then I need to put 7 microfarad capacitor. Yeah, that is okay. Then inductor at the top of it, and this IC is here, and then 1 nanofarad capacitor just very near to this ground and with the V out pin. Let's change the direction of it, because here in the diagram we little bit change the position. So let me put the cross here and also here. Now it's fine. Now we can design exactly the same in the same way as we have here in the data sheet. So let's do this one, and at the output we have to connect 100 microfarad capacitor, and then we have the Schottky diode in other direction here, just somewhere here. As I remember, but till that time I can just do it quickly. So I am using the USB just for the output, and I am putting the headers here. Okay, so it's something like this. And now let's see how I have to connect all these things. I already ignored this one, so we have a direct connection from here to here. And if you have a picture, if you will take a picture of this thing, then you just need to don't need to remember and just do the things so quickly. So now we have to do the connections here. Take the wire, connect this one with this one, and this one with the Schottky diode, and this external pin will be connected here after this, and this one will be going here, and we will try to align this one here, and another wire which could go for the ground, that will be connected here, and this will go to the ground. Okay, I think so. We are going so quickly and so well. So this one is connected to the V out, and the other end is connected to the ground. So in that case we can like do this, and we can increase the length of it. Okay, and at the output we were having the connection of it with, let me see, yeah, with the output pin. Okay, so we are just going to have a connection here, and just let me put it back a little bit here, and this connection will go in that way. Perfect. So we're just going to put here, and connection will be like this, and another connection will be like this. Okay, now see, this capacitor will be at the output, and we are just having we can just put a resistor or whatever here, but I want to have a connection for this header. In the same way, I will just ignore the remaining pins. How I can ignore? I can ignore like this, because otherwise when you will be doing the routing, then these open connection will make problem for you. So just go here and connect it here, and this point will be the at the ground side, and this point will be the this side, and then connect this one here, and this one is going to be connect here, and that's it. In other case you can also just put it high here and bring it more closer to this one. Both way is okay. Why I am using this one, that's why I should take 2 pins output with 5 volt. That is the whole schematic, if I am not wrong. This is ground, this is ground, and I already gave them the names. No, I think so. We have finished our complete schematic. So 3.7 volt will come here with the battery, and it will be purified. How it will work, I'm just explaining. It will be purified and the ripples will be removed with this 47 microfarad capacitor, and it will go to the inductor. Inductor will induce the amount of current here, and then this amount of current will pass through the Schottky diode, and it will store here, in somehow store here in this capacitor. And in the same way, this capacitor is already connected to the ground, and this 5 volts, which is the controlled 5 volts, with the help of this IC. And I already showed you the internal structure of this IC. I think so. I don't know exactly. Maybe here we can, if we will put the variable resistor at this point, then we can control the output of this structure of this schematic. Okay, this schematic, and then we are getting the 5 volt output here. And here I told you that with this schematic, with the calculation which we were having here, then by changing the values of these components, we can also change the output. And at the start, I told you that this IC is very nice, and we can change and we can adjust the output voltage of it by changing some values at the output. We can just change the output voltage. So which values we can change? And these 2 3 formulas are given here, and by having just little understanding of these formulas, we can change the output value which we are going to get here. That is the whole thing. It's not a very complicated structure, it's very easy. So our schematic is done. We just again try to save it. Okay, and now we have completed our schematic, and just go for the 3D design for it. So convert schematic to PCB. So if we have some problems, then we can see in DRC rules. Okay, let's go to the convert schematic to PCB. Okay, yeah, we just keep it in millimeters, the unit which we want to use here. And the copper layers, we are just going to use 2 copper layers. This is the X and Y height and width of this PCB. Just go for apply. If we have some problems, no, we have one problem is here. Let's see where it is. So one is design rule check errors. There is only one error. So let me see if we miss something. Okay, everything is connected here. Everything is also connected here. So let me see if all the connections are, because if we will zoom it, then we can see that all these connections are built well, because it happens sometimes this connection if stops here, and by having this we cannot see it. So that's why we have to keep it zoom, and we have to see everything, every joint so clearly, so all these connections are built well. Okay, save it again and convert schematic to PCB. Okay, now it's very good. We have zero design rule check errors. So we have no error here. So this is a very simple PCB. Just assemble it as it is. Okay, so this is the PCB, and I hope so we should. And one thing, when you are assembling or rearranging the components on the PCB, always keep those components which are connected closer. Try to keep them more close. Otherwise, in this way, you don't need to change, or you don't need to make long connections of the components here. That is the very easy way by which you can do this thing. So I am trying to put these components more closer to each other. Even I have more space in the PCB, and I will try to decrease the size of the PCB if I want later on. Okay, so one component is left, and I'll just put it here. and these components which will go in this way. Okay, what I am going to do, I will just decrease the size of the PCB, because in my opinion this size is much bigger for my PCB. So I will just decrease the size of it. And how I can do this? Okay, I am trying to keep it more simple for us, so we don't need to go and use more vias. Okay, I try to just do like this. Okay, yeah, I think so, that is okay. Okay, just like this. Try to keep it more straight. Okay, that's it. Yeah, I think that is fine. Try to keep it like this. So I decrease, why I make this type of size here, because when we are going to use this IC, this PCB in some like small, if you are traveling, then you have to have very small size of it. You just need to build the cell here and it will be okay for you. And what we are going to do, we just do the auto routing. We can also do like, we can also do the connections here, but see, now no vias even we need. So with direct connections we just built it here. And if you want that, I should teach you that how you can design these wires. So I can just delete this wire and just have a get this connection and just build between here to here. And you can also control the thickness of these wires, of these copper wires thickness, or the width, routing width in normal way, with the help of these things. Like 0.25 is normal one, so we are going to use this one. And second is the angle between, like these angles should not be more than 45. That is so good. Otherwise, if you have the angle more than 45, then it will, the losses will be more. So try to avoid this thing. And I think so, one thing is left, copper area. So try to do this copper area on the both layers. We put the copper area like this, click, click, and fourth click, and that's it. Okay, and also in the same way, we try to put the copper area also on the other side. I think so, yeah, that is okay, but I cannot see any copper area lining here, because otherwise it will become having different color here. As you see, we were unable to add copper area. This part of the video I am just adding after finishing the project. If you will do this part, then your copper area will be added. For that purpose, we have to see the schematic first. In this schematic, we don't have any ground. That's why we try to add the copper area, but we will not be able to add the copper area if we do not have any ground, because we want to put a copper area as a ground net. We have to add a ground here in the schematic. Just go to the common library, take a ground, just add it here. Now what we will do, put it in the middle like this. At this point, we just update our schematic. First of all, just save it. Now go to the design and update PCB. So no changes, the PCB already matches the schematic. Okay. Now we will add copper area. Now it will be added because we want to add a copper area as a ground. Just clicks here. First click, second, third, and fourth. And this is the top layer. And then right click. So this copper area is added at the top layer. And for the bottom layer, go to the bottom layer. Again add the copper area. Take copper area. Okay. First click, left click, second, third, and fourth. And then right click. That's it. So we add the copper area on both sides. First we see the 2D. So in 2D it will seems like this. And in 3D we can see it like this. Okay, one thing you can see here, okay, these two components, like these are the like headers, and you see when I will put the cell here, and you can just have it two wires here. If you will connect two wires here, and you will get 5 volts from here, if you don't want to get it from the USB port. So in USB port we can also get the 5 volt PCB, 5 volt power. And here you can see that I cannot see any component here. Why? Because let me show you here. That is the coin cell battery holder. This thing could happen to you, but that is okay. Just copy this one, go to the EasyEda or file here. Okay, here you will see that these components which we used here, maybe it is not available in the library. We can use another one, no problem. See, this component is available in LCSE library, but it is not available in JLCPCB assembled. So they can provide us, but they cannot assemble for us. In that case, what we can do, just go to the JLCPCB library. Okay, and try to put here like coin cell battery holder. Yes, even at the time when I was doing this, I was unable to get any coin cell battery holder. Maybe I am doing some mistake anywhere. Okay, I just go for 2032. I just put here 2032. Yeah, this one. It came up with the same one. And now it is okay. They don't have it in stock. At the same time, I see that we don't have this component in stock. So we'll try to use maybe this one. Battery base, yeah, it's also same, so we can use this one. So try to use this one and copy this manufacturing part number or GLC PCB number, GLC PCB part number here, and go here, go to the library, paste it here. Maybe they have it for us. Okay, minimum one we can order. That is so good, they have it and its price is very good. So we will use this one instead of this one. We delete this one and we use this one, and like this have a good connection. Yes, and now see, we have changing, we did the changings here. So what we will do now, just go for save, and at this point we need to do one thing, update PCB. Let's see what happened. There is no PCB under this project. Would you like to create one? Yes. Okay, they designed this thing for us. Okay, what we are going to do, we'll, I think so in that case we have to assemble that thing again in our, okay, we'll just do like this because this PCB is so simple, we'll just to redesign it. But in this case I think so I designed that previous previous PCB, maybe some in some other platform maybe, or under some other, how I can say, uh, project. That's why they were saying that I did not have any USB here. I did not have any project here under them. So okay, let's keep it here. Does it's okay? We have more space here. We can also decrease the space. For now, that is okay. You can also decrease the space, as I already told you how you can decrease it. So just save it. But if we have the project in the same sequence, when we updated the battery here, yeah, sorry, here at the time it was just when we did this thing update PCB, then automatically that component will be replaced there and we can just put it in the PCB again. We don't need to design everything from start. Keep it in our head. So I think so I did not design this PCB under the same project. Okay, let's check its auto route it. Okay, so he just need one via. That is okay. He just cross the lane once. That is okay. Now we'll go for 3D of it. And you can see here, you can also rearrange it and you can also play it with more nicely. And also we are getting here our 5-volt output from here and 5-volt output from the USB. This is almost the third part of this tutorial is end here. Now we will go for the fourth part where we will try to generate the bill of material and try to order the PCB, then how we can order it.